Maintenance activities and economics. According to the well-known Pareto principle, we can draw a clear conclusion. 20% of the most important maintenance actions can prevent up to 80% of failures. In other words, 20% of the tasks performed by the maintenance department generate 80% of the positive effects. That's why it is absolutely essential to identify and focus on those critical 20% of maintenance actions that bring the greatest value and real impact on reliability and performance. On the other hand, we must acknowledge that the remaining 80% of maintenance actions contribute only 20% of the positive results. And within that group, we will find a mix. Some of these actions are indeed useful, but many are simply irrelevant or bring no measurable value to the business. Therefore, optimization and reduction of such low-value or redundant tasks is necessary. A methodology that perfectly supports this type of decision-making process is the RCM strategy, Reliability-Centered Maintenance. RCM effectively separates essential maintenance tasks from those that are unnecessary, redundant, or ineffective. It allows us to focus resources on what truly matters. Excessive or inadequate maintenance. This is yet another serious problem in industrial maintenance. According to experts in the field of maintenance, between 40% and 60% of maintenance activities in industry add little or no real value. There are several reasons for this situation. First, duplication of maintenance tasks. This happens, for example, when two separate maintenance schedules overlap and the same task is repeated under both. Next, tasks are performed either too frequently or too infrequently. When intervals are not properly defined, it results in unnecessary labor or, conversely, insufficient maintenance that increases failure risk. Another cause is ineffective tasks that fail to prevent specific types of failures. In other words, even though certain inspections or overhauls are carried out, breakdowns still occur, because the maintenance actions are simply not suitable for preventing those types of failures. Also, in many plants, we see too many time-based and invasive inspections, which are typical of the second generation of maintenance, known as preventive maintenance. These inspections often disrupt production and increase costs, but they could be more effective, less expensive, and less disruptive if they were based on the actual condition of the equipment. That's the approach of the third generation of maintenance, also known as predictive maintenance, which relies on condition monitoring of critical components and systems to perform maintenance only when necessary. And finally, there is often a failure to utilize available failure data and operational experience to determine the appropriate frequency of tasks. Without proper analysis, we don't know how often maintenance should be performed, whether it's preventive replacements, predictive measurements, or condition-based inspections. This material is an excerpt from the course Maintenance Mastery. Want to learn more? Visit rcm2.org.